Hello everyone, here is a question based on colligative properties. 2 gram of a non-electrolyte solute dissolved in 75 gram of benzene lowered the freezing point of benzene by 0.20 Kelvin. The freezing point depression constant of benzene is 5.12 Kelvin kilogram per mole. Find the molar mass of the solute. We know that depression in freezing point delta Tf is equal to I times Kf times m. Here I is the van der factor. For non-electrolytes, van der factor will be equal to 1 and therefore it is completely okay to write Kf times m provided if the solute is a non-electrolyte, and Kf is the molar freezing point depression constant and m is the molality of the solution, and therefore molality is equal to number of moles of solute divided by mass of the solvent in kilogram, and therefore delta Tf in this case will become the number of moles of solute is equal to mass divided by molar mass of the solute. So let us take the solvent weight as component 1. So we will take W1 for the mass of the solvent just to simplify the equation. So this is the solvent mass and W2 is the solute mass. Therefore we can simplify the equation, and therefore delta Tf is equal to Kf times W2 because solute divided by mass of the solvent, that is W1, and we have to use the molar mass. So molar mass, let us take it as M2 times we require the W1 in kilogram, and therefore here we are multiplying with 1 kg divided by 1000 gram, and this 1000 gram comes up, and therefore we can rearrange this equation as Kf times W2 times 1000 provided if the W1 is given in grams, okay, divided by M2 times W1. So this is for delta Tf, but now here we are going to determine the molar mass of the solute, and therefore we need to exchange this. So M2 comes here, delta Tf goes here, therefore M2 the molar mass is equal to Kf times W2 times 1000 divided by delta Tf times W1. Here Kf is given as 5.12 Kelvin kilogram per mole, W2 is given as 2 gram times 1000 divided by delta Tf is given as 0.20 Kelvin, and then W1 is given as 75 gram mass of the solvent, and therefore we can cancel the common things here. So we have kg here, we have gram here, so kg we can cancel, Kelvin we can cancel, gram also we can cancel. So molar mass will be in gram per mole. So this will be equal to 5.112 times 1000 is 5120, 5120 times 2 is equal to 10,240 divided by 0.20 is 1 by 5, and therefore 1 by 5 means that 75 divided by 5, 75 divided by 5 will become, this will be 2 remaining, so 15. So here we will have 15 gram per mole, this will be 3 times, so this will be here 3 times 5 is 15, so here 2 times 5, and then we cannot do 2 by 5, and therefore let us put a 0, and then for 24 it will be 4 times 5 is 20, so 4 remaining 4, 40, so 40, so that will be 8 times 5, so 2048 divided by 3, so that will be 6 times 3 is 18, remaining 2, and then bring down the 4, so 8 times 3 is 24, so that will become exactly 0, but we still have a 8, and therefore 2 times, so that will become remaining 2 times 3 is 6, remaining 2, so rise it to the decimal, and that will be keep going as 66. So the molar mass is equal to 682.66 gram per mole. That's the correct answer here.